Namaste everyone, girls and boys on this platform. First of all, our main focus to make things or to make big things in very easy way. This should be our concern. Means how to fragment tough challenge in very easy way. Okay, first of all, on this platform, our task to discuss uh, about competitive examinations like IIT Advanced, Main, Neet, various Olympiads, KVPY, as well as for your intermediate examinations. These are our main concern. Okay. Now, I am speaking loud so that my voice could accessible to all of you. Okay. See, today we are going to discuss speed of sound waves. Okay. Before starting this topic, I'd like to discuss basics of sound. Okay. See, so you know sound is nothing but flow of pressure. Okay. Means as compared to the atmospheric pressure, even loud sound change pressure by a small amount, or by putting huge sound, high intensity sound, you can't change density of the medium. Suppose here density is, suppose 1.28 kg per meter cube, here oxygen nitrogen densities. After projecting huge sound, even you project huge sound, density can't change by appreciable extent or by huge amount. Okay, young mind? So these are the points. Now, another point, here oxygen nitrogen molecules are not separated by very big distance. Okay, see, here is one oxygen, here is one oxygen. No, oxygen and nitrogen separated by very small distance. Means oxygen nitrogen molecules closely spaced. Do you know the distance on an average? Yes, 10 to the power minus 9 meter. 10 to the power minus 9 meter means much smaller than vegetable polythene bags. Okay. One more thing. Even you project huge sound, loud sound, okay, genius, then oxygen and nitrogen molecules vibrate by what amplitude? It vibrates by amplitude of 10 to the power minus 6 meter. Okay, means in atmosphere, if you project a very huge sound, amplitude of the order of 10 to the power minus 6 meter, means equals to approximately vegetable polythene bag. Okay. Now next, by projecting sound means you are projecting pressure. You are projecting pressure in the medium. Okay. So now when you project pressure in the medium, then okay, some points carry compression, some point carry obviously rarefactions. Compressions means air molecules compressed, means temperature of this region increase. Rarefaction means temperature of this region decrease. Okay, so please, if you project the sound, compression and rarefactions or pressure changes by very fastly. Okay, pressure changes very fastly. Means compression and rarefaction forms form rapidly. Due to this compression, obviously compressions has high temperature as compared to rarefactions. So these are the reasons transferred only work, not transfer heat. Compression becomes little hotter, rarefaction becomes little cooler. Compressions can't transfer heat to rarefaction. Please, okay? Means, please remember, compression and rarefactions, I know, high pressure zone or low pressure zone respectively. So, these two can't exchange heat because these pressures region form rapidly. है ना? Or in addition to this, air molecules insulator also. Okay. Now, young mind genius, please, these are the few points you should keep remember. Okay. See, now we are going to start sound expression of sound waves. Okay. See, in this topic, see the proof here. Suppose this is the part of atmosphere. Okay, we are taking this area, suppose dA, right? Now suppose sound is entering from left to this portion. In this air portion, sound not penetrated yet. Okay, because sound is just in the left. See, P atmosphere plus dps. Dps stands what? This pressure is due to sound. Here we wrote, okay, pressure due to sound. Okay, means you know genius, sound creates oscillatory pressure. Okay, see, so here is written dps stands what? Pressure due to sound waves. Now please try. Now suppose this sound, this dps pressure goes inside and take time dt. Okay, because dp, you know, in science everything is finite. Means you need to define all parameters. So I am defining here dps means sound pressure. Okay, here I am defining. So I am defining a dimension of dps. Suppose dps penetrates up to time dt. Okay, so suppose this penetrates up to time dt. Then now final comes, okay, final comes what? I am just writing. See, now I just drew this figure. Please see here, sound wave means pressure just entering to this air molecules. Okay, it takes time, suppose a small time it takes, suppose dt, because you know this sound, this parameter means pressure due to sound has some dimensions, because everything is finite. So suppose this penetrates of this normal air up to time dt. Okay, so now this air finally compressed by a small amount, because as I said, by providing sound, by transferring sound in normal air, density can't change by big amount. Okay, now see this, focus on, pay attention on this diagram. Okay, now please see, before projecting sound wave, where is the center of mass? Center of mass is at here. Okay, or what is the position of center of mass? The DL air. DL, this A subscript stands air, means at this situation sound wave not penetrated. Okay, so center of mass where lies? The center of mass lies from the right of this demarcated line DLA by 2. This is, I think, as I said, little conceptual derivations. Please pay attention. Now see here, after penetrating the sound waves, what is the new center of mass? Suppose this pressure due to sound wave penetrated this normal air and reaches here. It takes time dt. Suppose it takes time, after penetrating, takes time dt. So now where is the new center of mass? New center of mass is at here. This is the final center of mass position. So could you write please? dLs by 2. S stands what? S stands here when sound waves penetrated in normal air. Then where is the center of mass now? The center of mass is now dLs by 2. Okay, genius? Now please see. After this, okay. Now the basics. All acting forces pass through center of mass. At the left side, pressure acting PA plus dps, and right side P atmospheric. After penetrating to here also PA plus dps, and here is P atmospheric. Okay. Now after writing this, please see. Now apply equation of motion. Do you know equation of motion? S equals ut plus half at square. Yes, we know equation of motion. So S means what distance center of mass displace. Means what is the displacement of center of mass? The center of mass displaces by, please, this is the final and this is the initial. The center of mass displaces by dl air by 2 minus dl s by 2. This is the displacement of this air molecules. Okay, please see here. This is the initial position of Cm. Now this is the final position of Cm. So Cm shifted by what amount? Cm shifted in this direction. By what amount? This amount. Now please write here half, quite triumphing, try. Half A. A means acceleration. So acceleration means what? The force how much? The left direction how much force? So multiply by area. Here you also multiply by area. In this direction how much excessive force acts? The force will be APA cancelled. Now only A dps survived. The force acceleration, here is acceleration. Acceleration means force. Force by what? Mass. So since this sends, please genius, this sends only pressure. Okay. So this means air molecules remain the same approximately. Okay. So could you write please here area into density, volume of the air molecules. Area into length gives what? Volume. And volume into density gives what? Mass of the air molecules. Okay. Now please. Now this is half. This is acceleration or dt square. dt square means time square. This is, here is time square. The time square, at the place of time square, what you write, genius? At the place of time square, please write here. Time square means since sound wave reach from here to here, okay, sound wave reach from here to here, है ना? So could you write please here dLA by velocity of sound, okay, means velocity of sound means this gives what? Time, है ना? Because here is dt square, could you write please? Length divided by speed of sound means what? Pressure. Okay, so after writing this, now please see here. Could you write please? Half cancel on both sides. You will be getting what? dLA minus dLs equals dps by rho. dl get cancelled. Then you will be getting vs square dl. Further, could you write please? Vs square, very important equation is coming, please focus. Vs square dps, okay, by rho dLA minus dLs divided by dLA. Okay, see one thing, multiply here by 8. So you will be getting what? Vs square dps rho, this is volume change, or volume change defined means final minus initial, so keep mind negative outside. So you will get volume by, this is original volume of air. Okay, now please see here. Could you write please? Vs square rho dps by dv by v. Please see, very important results. Very important result is coming. Okay, see here. You know, sound wave here give how much pressure? dps. Okay, means surrounding air molecules facing pressure, surrounding molecules facing pressure due to sound wave with value dps. So this gives, this change in pressure gives change in volume. Okay, means this is called a stress and this is called a strain. Okay, this shows this parameter. I am just blocking. This parameter represents elasticity. Okay, this parameter, since this parameter represents elasticity, actually this is called bulk modulus of elasticity. So could you write please Vs square equal to B by rho? Now please see. The Vs equals to B by rho. Means this gives velocity of sound waves. Okay, please keep this formula in your mind. You know, since propagation of compression and rarefactions, sound wave is nothing but what? Flow of pressure. The sound wave is nothing but flow of pressure. Okay, means compression and rarefaction flows, है ना, flow. So since and additionally process is what, adiabatic, है ना. So you know what is the modulus of elasticity related to adiabatic process? So modulus of elasticity related to adiabatic process is nothing but gamma into P. P is pressure or gamma adiabatic constant. So what is the velocity of sound? The velocity of sound comes under root gamma P by D. Okay? Namaste.